We are still working on topic 8.12 here. Or actually, we're starting to work on topic 8.12. How do you calculate the volume of a washer using a washer method and a shifted axis? And I can calculate the volumes of revolution using definite integrals. And this should have said the washer method with a shifted axis of revolution. We're going to see three different types of examples overall. I'm actually going to start with example 2 because I think it's a little bit easier to see this one and build up to, we'll go back to example 1. So we're going to find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the line y equals -2. So we've got this line y equals -2. That's going to be our axis of rotation because it's after the word about. So let's see if I can find my region to begin with. So they gave me the picture. So that's the x squared part. I should have probably used the same colors, huh? X equals 0 is y equals 0, not x equals 0. Y equals 0 is the x-axis. Then they say we're going to use the line x equals 1, which is the green already in the picture, and then the brown, which I don't have, so it's like my orange, is this. So the region that we are revolving is this region right here. Then it's saying we're going to take that region and we're going to revolve it around this line y equals -2, which would be down here. So this is our new axis of revolution. And notice that there's a huge gap, right? We've got a gap in there. So we know that we have to do a washer. Looking at the picture, it looks like the blue one is the outer function and the red one is the inner function. I know it seems weird that a horizontal line is the inner function, but that's the way it is. All right, so let's go ahead and set up our integration. Whenever we do a volume of revolution, we know we start with pi. And given the nature of this problem, it looks like we can just read the bounds off the graph. It looks like we're going from 0 to 1 again. My outer function first. So I'm going to go outer squared, and then I know it's top minus bottom. Remember, your top is the blue, and your bottom is going to be the axis of rotation, which was y equals -2. So top is x squared plus 1 minus the bottom, which is -2. All right, and then we're going to subtract the whole thing from our inner function. Whoops, I forgot the, oh no, dx at the end. Okay, and then the inner function is y equals 0. So I'm going to go 0 minus the axis of rotation, which is -2. So all of these double negatives are going to go ahead and go positive. Let's clean this up a little bit before we integrate it. I should have written in a different spot. I'm going to move my work over here. So we've got volume equals pi times the integral from 0 to 1. 1 plus 2 would be 3. So we've got x squared plus 3 squared. And then 2 squared would be 4, so -4 dx. I'm going to choose to FOIL this out a little bit. So I've really got x squared plus 3 times x squared plus 3 minus 4 dx. X squared times x squared is x to the 4th. X squared times 3 would be 3x squared, but I have another one of those in the middle, which is going to make it 6x squared. And then 3 times 3 is 9. All right, in our next line of work here, we're going to put the 9 and the 4 together. So all I'm doing is a bunch of algebra. So it's going to be plus 5. So a bunch of algebra to get me set up so I can actually do the integration. So now I'm ready to integrate. So we've got pi. The integral of x to the 4th would be x to the 5th over 5 plus 6x to the 3rd over 3 plus 5x, and then from 0 to 1. I'm going to put my 1 in. So 1 to the 5th is 1/5. These are technically going to cancel, and I'm not going to go to the simplifying line. I'm just going to do it in my head. So 1 cubed is 1 times 2 is 2. And then 5 times 1 would be 5. And if you think about it, when I put the 0 in there, it's going to be 0, 0, 0. So I'm subtracting 0. I really don't even need to write it down. That is actually a good answer. You don't have to do more than that. I could make them all common denominators of 5. So if I multiply 2 by 5, I get 10. If I multiply 5 by 5, I get 25. And if I add those up, I end up getting 36 pi over 5.